Extraction of iron. 1. Preliminary treatment. Hematite, magnetite, limonite and siderite are the main ores of iron. Most of the iron ores have high concentration of the metal. When the concentration is low, the ore is given a suitable preliminary treatment from the following. 1. Washing. Iron oxide ores can be concentrated by this method. In this method, the crushed and finely powdered ore is washed with a stream of water. The gangue particles are lighter than the ore particles. Therefore, the gangue particles are washed away while the heavier ore particles stay behind. 2. Magnetic separation. Iron ore with magnetic property, that is magnetite, is enriched by using magnetic separators. A magnetic separator consists of a leather belt that moves over two rollers. One of the rollers is an electromagnet. The finely powdered ore is dropped over the moving belt at one end. When the ore falls down from the moving belt at the other end, the iron-containing magnetic component of the ore is attracted by the magnet and forms a heap near the roller. The non-magnetic impurities, that is gangue, fall away from the magnetic ore and form a separate heap. 2. Reduction. In the extraction of iron, carbon is used to bring about reduction of iron ore. The reduction is brought about in a blast furnace. The blast furnace is a 20 to 40 meter high cylindrical furnace. It is narrow at the top and the bottom. The mouth of the furnace is closed by a cup and cone feeder. The outer shell of the furnace is made up of steel plates. Inside this, there is ordinary brickwork which has about a 0.4 meter thick lining of fire bricks. There is an outlet at the throat of the furnace for hot waste gases. At the bottom, there is an outlet for molten iron. Above this, there is an outlet for molten slag. At the highest level in the bottom part of the furnace are blowpipes for forcing in blasts of hot air. The iron ore is mixed with coke, which is a form of coal and limestone. This mixture is called charge. The charge is filled in the cup of the feeder. On lowering the cone, the charge gets automatically introduced in the furnace. A blast of hot air is blown in through the blowpipes near the base of the furnace. Oxygen in the hot air combines or oxidizes with the coke in the descending charge to form carbon dioxide. This reaction is highly exothermic. The heat liberated in this reaction brings about various endothermic reactions in the furnace to produce iron and slag. In the middle region of the blast furnace, the temperature is very high, approximately 1200 to 2000 degrees Celsius. At this temperature, the iron and slag formed are in molten state. The reactions in the blast furnace are as shown. 1. Coke reacts with oxygen to give out carbon dioxide and heat. 2. Limestone is decomposed to lime and carbon dioxide gas is released. 3. Carbon dioxide reacts with coke to give carbon monoxide. 4. The iron ore reacts with carbon monoxide to give molten iron and gaseous carbon dioxide. 5. Calcium oxide reacts with silica to give calcium silicate or slag. It can be seen from the reactions that the iron oxide gets reduced to metallic iron by carbon monoxide. The gangue in the ore, sand or silica, Si2, reacts with the lime formed by the limestone in the charge and forms the slag, which is calcium silicate. Both the products, the metallic iron and the slag, are in molten state at the high temperature in the blast furnace. These trickle down the furnace. The slag is lighter than the molten iron and also does not mix with it. As a result, the molten slag forms a layer on top of the layer of the molten iron. Because of this, the molten iron is protected from oxidation by oxygen in the blast of hot air. The molten iron and molten slag are drawn through separate outlets from time to time. The molten iron obtained from the blast furnace is poured in molds where it gets solidified on cooling. It is then called pig iron or cast iron. The cast iron contains impurities. The major impurity is carbon, which is up to 4%. This makes the cast iron hard and brittle. Cast iron has limited applications. Most molten iron is converted into steel. The molten slag, after solidification, is used for road building.